Thanks everyone who watched the first video. It did way better than I expected. So many great comments too. I tried to answer as many as I could, but I'm sorry if I didn't get round to answering your question. I'm going to do a series of shorts answering some of the most common questions. In the first video, I got basic world generation working. Now I wanted the world to feel more like a planet. If you look out now at the sky, you can see it's the Unity default skybox. It looks rubbish. What we need is an atmosphere. This is my first attempt at an atmosphere. It's a volumetric atmosphere that uses Rayleigh scattering, which is the same type of scattering that makes the sky blue on Earth. In a nutshell, the atmosphere scatters light from the sun, but it scatters shorter wavelengths more. This spreads that light out across the sky, which then can be re-scattered back into your eye. Seeing as blue light has the shortest wavelength, this means that the sky turns blue. During sunsets and sunrises, light has to travel further through the atmosphere. This scatters out more light, leaving just the long wavelength red light. Sebastian League has a great video on this, which I'll link in the description if you want to learn more. My implementation uses a render feature to do a full screen pass, which uses a depth texture along with a lookup table to calculate how much atmosphere the light will have travelled through. This then adds that light to the screen pixel, calculated from the scattering constants. This implementation was very buggy and laggy, and needed a lot of work. I also needed to write unrealistic scattering calculations, as on Earth the atmosphere is very thin compared to the planet's radius, about 1%. However, on my tiny planets, the atmosphere is comparable to the planet's radius. This means that when the sun is low on the horizon, it's not travelling through enough atmosphere to give you a red sunset. After a lot of tweaking and head scratching, this is the improved atmosphere. It's much less laggy, and it scales correctly with planet size now. It looks a lot more realistic. I've also added a sun, and the stars now come out at night too. What's cool about this as well is you can fly back away from your planet, and you now see that lovely glow around your planet. This is super important for PlanetSmith, as in the future I plan to add space travel. So if you blast off from your planet, I want you to be able to see the whole planet with this lovely glow around it. The cool thing about this implementation is we can tweak the constants, the scattering constants, to change how the atmosphere looks. This way we can have alien worlds with really crazy looking atmospheres. Here I'm making it scatter less right, and we've now got this cool pink atmosphere, but there's effectively no color that we couldn't make the atmosphere. I was now really happy with how the game was forming. I had proven that you could make seamless worlds and have a cool atmosphere to make it look like a real planet. It was now time to make some editor tools and make the core of the game solid so I could be confident in making a fully fledged game, not just a cool thing to look at. The weird thing about Voxel games, and PlanetSmith is no different, is that the world is an illusion. It feels so solid. As you dig down through the planet, as soon as you remove a block, you see the blocks below. But in reality, the blocks below weren't really there at all. What actually happened was as soon as you removed that top block, the world rebuilt itself instantly and created the box below. This has to happen seamlessly, or the illusion is broken and the immersion is lost for the player. If I now switch to the editor view, you can see how the world is just a thin skin and has no thickness. Also, if I select a voxel, it's not just one block, it's a collection of blocks called a chunk. This is not normal for games, so let's look at what normally happens in games and why we can't do that, as understanding the reason why we combine all the blocks together will help us make better design choices going forward. The traditional way is to have each block be a mesh, like this. Have a UV map on that mesh which tells the shader where to draw the textures in the material. This provides a great workflow, as each block will have its own texture for an artist to modify, and they can even see their changes update in real time. This all sounds good, and normally it is, even for thousands of objects. but it doesn't scale well, and we can have billions of voxels loaded at any one time. The reason it scales badly is because of the way your computer renders objects. To draw an object on your screen, your CPU selects an object for rendering. It then takes that object's mesh and its material and sends it to the GPU. The GPU then uses the mesh and material to render it to your screen. It turns out that sending the mesh and material to the GPU is a very slow process. Drawing the mesh is actually really fast. If we have billions of different objects, that means that we need to send the mesh and the material to the GPU billions of times, and you'll get exactly 0 frames per second, if your computer hasn't crashed already. So what if instead we sent the mesh and the model to the GPU once, then rendered the mesh in multiple different places? For example, render all grass blocks on screen at once. This is called instancing, and yes, this is much better, but we'll still have to send a new material for each voxel type. This method though requires a lot of positional data, and at the scales we're talking about, this would require you to have hundreds of gigabytes of RAM, not something that most people have. This is the reason we group areas of our world together into chunks. We then create one mesh per chunk, and therefore only get one draw call per chunk. However, this brings about a new set of issues. As you can see, this mesh contains multiple different textures, but we can only have one material per render pass. So somehow we need to combine every texture in the game together into one mega texture. This is called an atlas. We take one large texture and break it up into tiles, one tile per texture. I chose to have 32 by 32 tiles. This allows us to have 1024 different textures in the game. Now instead of having the UVs mapped to one texture, we map the UVs to a tile. We then offset the UVs in code to get the texture we want for the voxel. Great, another problem solved. However, we've just opened up a whole new can of worms. Firstly, this mega texture is huge. It's 16,000 by 16,000 pixels and 1 gigabyte in size, making it slow and awkward to work with. Also, each voxel is now tiled to a linked offset in the game's code. If someone accidentally moves a texture, the game breaks. Also, if you accidentally go over an edge by 1 pixel, the game breaks. And to make things even worse, we can no longer easily preview a texture without running the game. I wanted to get back closer to that more traditional way we make textures for games. One texture per voxel, so artists or myself could easily make and modify textures, or perhaps players if we release texture packs in the future. To do this, I made a voxel manager. Its job is to store every voxel in the game, store the properties for that voxel, store its texture, give artists a way to preview the voxel, and most importantly, combine everything automatically into an atlas, which matches the voxel data. If I click a voxel, you get this nice preview at the bottom. You can see its properties here, so we can change how the voxel behaves in the world, and most importantly, you can set the textures. I chose to have physically based textures, so you can get a few extra texture maps, which change how the voxel will interact with light. If I click this button at the top here, the 6 atlases are rebuilt automatically and the game's textures are all updated. This manager is the key to making it easy for people to work on the game. Now that was working, I was able to get an artist on board to help turn my prototype art into something that actually looks cool. Here are some of the new textures. They all have a consistent style now, which we can use to give the game a coherent feel. I also kept adding to the manager, adding a pop-out for each voxel, different preview options and cool stuff like a color picker, so we can reuse textures, tinting blocks, different colors. There's also this cool feature where you can copy a texture from a different voxel. This way we don't get any duplicate textures. Another important thing I needed to make was a structure editor. The trees you saw in World Generation in the last episode were hard-coded. This was fine for the proof of concept, but not practical for actual development. The structure editor is a simple editor window that lets you place voxels. The green marker shows you the structure's origin, and you can place and remove blocks as if you were playing the game. It still needs some more features, but it's good enough for now to make some trees and some buildings. When you're happy with your building, you can save it into a scriptable object that can be accessed during world generation. Here is everything I did for this episode, put together, along with some shiny new textures from my artist, in a world. We also have grass now. These are just cards, but they add so much to the world. Some of the trees here are not spawning correctly. They have been chopped in half vertically. This was due to them not generating over chunk boundaries. The sky is working. It's a little dark, but the sun is working and moving across the sky. The world feels a lot better to explore now, and making houses is fun, even though we still have very limited number of blocks. If I fly up into the sky, you can still see some of the chunks generating. At this time, they weren't prioritizing what was closest to the player, so sometimes you'd get some loading that should have already loaded. And as you fly around, it's great to see the stuff popping out over the horizon with the curvature of the world. The block breaking is now super smooth as well. As you can see, I'm breaking blocks really quickly here and no lag spikes at all. And same goes for placing blocks. That just about does it for this episode. For a bit of fun at the end, here is a tool I added which gives you the ability to spawn structures. This won't be in the game, but is very fun to play with in the editor. This really highlights how quick the world updating is. The building is popping into existence instantly. In reality, remember, multiple chunks have to recreate their mesh. You can still see some lag spikes, but this was coming from a mistake I made with collision mesh generation. I'll fix that in a future episode. Thanks for staying until the end. In the next episode, I'm going to go back to world generation. It's time to write that from the ground up and make it easy to tweak and add new biome types. If you have enjoyed this episode, don't forget to add PlanetSmith to your wish lists on Steam. You can find a link in the description. This is one of the best ways you can help the project, as well as subscribing here on YouTube. If you just can't wait until the next episode, you can always join us on Discord and get all the latest PlanetSmith news. It's the best place to ask questions or tell me your ideas and find other people who are also excited about PlanetSmith. The link is also in the description. Finally, I'm going to answer the most common question from the last video. Yes, the blocks do get larger as you build up in the world. The effect is small though, and not noticeable on standard worlds, but if you're on a tiny planet, it can be an issue. This will be addressed by capping build height in tiny worlds, and blocks placed too high will detach and drift off into space. Thanks for watching. I'll see you in the next one.